Okay, so this is gonna be working on helping kids solve the problems proportionally with the gas laws. So presumably through your labs, you already had kids pull out the idea that if we increase volume, that we decrease pressure, and then if we decrease volume, we increase pressure. I did those labs, and as we did the graph, had kids do the whiteboards, talk about the graphs, and I had about 10 minutes left in class each of those days. I introduced them to the idea of the math problems instead of waiting for the worksheet, which is after all 3 labs. So I picked a couple random points, and I set up like what would be like a pretty typical looking problem. Something like, all right, at volume 1, you have 50 milliliters, and you get a pressure reading of, let's say, 1.01 ATMs. And that volume 2, the pressure is going to go up to 75 milliliters. What's going to happen to your new pressure? I talked to them a little bit about the idea that the volume physically, the change in the volume physically changes the pressure. So when I increase the volume, that physical reality is changing the pressure. And then I sort of set up the math the same way, showing them that like, hey, in real life, this makes this change. Well, in our math, we can make this change. I did kind of like a gradual release with them. So I did modeled one for them, like just thinking aloud. Then I had them do one with me, then do one in a group, then finally do one on your own. So I went through and I showed them like, okay, so how can we make the volume make this change? Well, if we know this is the thing we want to change and we're going to do this math problem, we're going to start with this, and we are going to do some math to it that's going to make it change. So I know, Chuck, you were worried about the units. This kind of just gets rid of that altogether. There's nothing they can do. So then I said, all right, so what do we think is going to happen here? The volume went up. What's going to happen to the pressure? Since this is sitting here, most kids were able to say pressure is going to go down. And then I said, all right, so I'm going to set up a proportion that's going to make this go down. So I would talk them through this a little bit, and I'd say, okay, what do you guys think happened here? Most kids would be able to say that that went up by 1.5 times. So it's 3/2 bigger. When we did the lab, we brought out the idea that this was inverse, all right? So that if this went up by 1.5 times, or it went up by 3/2, what would we have to do to make the inverse happen? Kids, with this ratio, kids can say, okay, well, I know that the inverse of that is 2/3 pretty much. So I said, all right, so we want to make sure that we're setting this up, that this pressure has to go down by a ratio of 2/3. How can we mathematically reflect the reality of what happened? In real life, volume going up makes pressure go down. I can go over here and I can say, I can set this up as 50/75 or as 75/50. Which one of these two things is going to make that go down and make it go down by this proportion? And most of the kids could make sense out of me saying, I think if I go like this and put the big number on the bottom, that when I do my math, it's going to go down by the same proportion that it needs to. So do all that, get on the math, and you get your answer. And then it seemed to be